All right, greetings. Welcome. It's not the preferred way to be doing logic these days, but when you have a snow day, then you get me via video. So good luck with that as usual. Email me, text me, whatever if you have questions. Obviously, we will be covering this again next week. So read your materials, plug away on your exercises, that kind of stuff, and we'll hopefully this will be a one-shot deal, and we'll not make a habit of this. Certainly not my intention. So let's walk through our lesson for today. So this is lessons 5 through 7 for intermediate logic, weeks 3 and 4. This is being recorded for week 3 since we're having a snow day. So let's just dive in, and I'll trust you will let me know if you have questions. You start with Dilbert, right? Dick from the internet. Would you lie to a monster to keep a baby alive? Yes. Ha! You admit you're a liar. Not most of the time. Oh, not most of the time. Ha ha! Look who's trying to walk it back now. Apologize for hating babies most of the time. I never said that. Wow, pathological much? Folks, this is what happens when we have bad logic, bad reasoning. And yet, this seems to be the way in which we have so many arguments these days. And so I just put these up there to keep you thinking about there are real world applications of these things. And so keep reasoning well, keep plugging away at your logic. Let's launch into our materials for today. So lesson 5, biconditional. Definition of biconditional: if and only if propositions. True only when both component propositions have the same truth value. So they must always be, so they're both true, both false. Only when they have the same truth value are they true. Otherwise they are false. False when the truth values differ. This is the easiest one. So they're either, if they're in agreement, they're true. If they're different, they're false, right? Okay. So here's an example of a truth table for P and Q. You see that in every instance where they are the same. So P true, Q true, then it's true. Anywhere where they're at in opposition to each other, true, false, then it's false. This one's pretty easy, just because of that fact. So let's keep moving along. I'll put this up here. I'm going to do like I usually do, and that is let's run through the material first. But let me put this up here. And the beauty of doing this via video is you can pause and you can work on this and do it, and then we'll come back and we'll work on a few of these. We'll save a few of them for next time, for next week. But you can at least take the time, pause the video, try to translate the argument that's being made, do the truth table, and then we'll do some of them together this week, and we'll do others next week. But at least you'll have seen them and have a chance to work through, and you can impress your logic teacher that way, right? So complete the truth table for the compound proposition P and Q, or not P and not Q. Okay, so you could do the truth table for that. Okay, here's the next. Well, I have that twice in a row, don't I? So here's the truth table for that argument. I put it in an actual table just because it's easier to display it, right? So let's see, this is the challenge. So when you look at on this line, right? We're looking on this line, and you got to work your way all the way through your table. And you have to do each individual proposition. You have to do the negated version of it, since that's negated in this. Then you need to do each of the operators individually and then put them together with disjunction. And finally, this has the same truth compound for that, right? So here we go. Lesson 6, logical equivalence and contradiction. Definitions. Logically equivalent. Two propositions are logically equivalent if and only if they have identical truth values. So we're going to have to be able to tell the difference between what is equivalent. We're going to use the word consistent, and then we're going to use the word valid or validity as we move forward with this, okay? Equivalent, if they're equal to each other, they have to be the same on every single line. The proposition has the same truth every single line for equivalence, okay? A tautology, a proposition which is true for every row in the truth table, okay? Statements which are true by logical structure. Right, these are ideas that we introduced in introductory logic, but now we're going to represent them on the truth table, okay? And so, to be equivalent, every row, the final row on your truth table, every row, as you compare two propositions, and they can be compound propositions, right? They have to be identical every single row. Tautology, they have to be true on every single row. And so that just these are the things you need to be memorizing, and you need to learn their differences, because all the way through the semester you'll be using this stuff, okay? Then there's self-contradiction. If a tautology is true for every single row, what do you think about self-contradiction? It will be false for every single row. Statements which are false by logical structure, such as P and not P. So when you're a negated proposition, P and not P, they are a self-contradiction, and to know whether it is a self-contradiction, is false on every single row. Let's keep moving. Key points. The biconditional can be used to test for equivalence. If the biconditional of two statements is a tautology, then the statements are equivalent. Okay? If the biconditional of two statements is a tautology, true for every row, then the statements are equivalent. The biconditional can be used to test for contradiction. If the biconditional of two statements is a self-contradiction, then the statements are contradictory. Remember, self-contradiction, false every single row. Okay? Tautology, true every row. Self-contradiction, false every row. They are equivalent if they have the same truth value for every single row. Let's keep moving. So here's additional. Determine whether the following pairs of propositions are equivalent, contradictory, or neither. Okay? So you have P, if P, then not P. Not P, if not P, then P. Okay? And so when you do this again, you need to do, you're going to have to do P, a row P and not P, but think about how many rows are you going to need for this. I'm going to pause right there, and just to give you an extra second to pause the video, see if you could do the truth table, and then let's work it out. So you pause. I'm going to keep moving along in my time, and so now we have if P, then not P. Not P. And so we're going to see if they are equivalent. So we're going to create, essentially what we're going to do is create a biconditional. So let's do a truth table for these. Okay, so P, true, false, right? Since I have only one variable, I only need two rows, right? So if I have, and I'm going to do this in a more compact format. Okay, just because it makes it easier. I mean, you can, and I would suggest maybe at the beginning here that you would take the time to do your whole thing. So let me write over here so that you would do P, and you would do not P, and then you would do if P, then not P, right? You do that as a proposition. My issue I have here on the screen is space. And then you would also do not P. If not P, then P. But let me show you what I'm going to do, and that is I'm going to, if my skills are up to date, I'm gonna make this compact and suggest this is another way for you to do your truth tables, and that as we move forward will become a little more standard, just for the sake of saving space. I'll try it if I. Okay, so I have P, true, false. Not P is going to be false, true, right? Okay. And so all I'm going to do on the right side here is carry over the same truth values from there. So not P is false, true. See that? It's the same. These two are the same. So I'm just going to do false, true. And then for P, I'm going to do true, false. Let me, whoops, let me go back here. I'm trying to see if I can bring my colors up. There we go. I'm a little out of practice with doing this online. It's a challenge. So now that I have those truth values, think about for conditional, under what circumstances does conditional work? Now we're used to having 4 rows. In this case, we only have the 2 rows. So you got to remember, what's our rule of thumb is that unless for the conditional, unless it is the first one we have, which is true, false, we always we're assuming that the antecedent is true, and that when that's the case, then you look at the consequent, right? And so we have true, false in this case. So the first one is false. See how I'm doing this in blue? So I'm doing this under this operator, under the conditional operator. And then we want to have false, true, right? It's true. Okay. Now I'm going to do under this operator, false, true, true, false. Right? Okay, so now let me change my color again here just so that we can see. So now when I look at these, right, I look at them across, and what I'm looking at here now is I'm looking at false, true on that line. See that? False, true. And then true, false. Okay. Essentially what I'm doing here is, if you think of it like what we're doing is, when I'm determining whether they're equivalent, contradictory, or neither, these are the opposite on every single line, right? And so this is contradictory. Okay. They're a contradiction. You could think of it this way, and let me change my colors again here, and let's go orange. You can think of this as a biconditional. Okay, if I create a biconditional, now again I'm looking at the blue, false, true. The biconditional values of these would be, this would be false, right? Because I'm doing under the biconditional, false and false, because they don't agree. And so both lines are contradictory, and so they're both false, and that's what makes this contradictory. Okay, you guys can try the other ones. Let's keep moving along though. All right. Again, we're determining. Here's another one: P or Q, not P or not Q, not P or not Q. We'll come back and we'll do these. I'm just going to put it up there. You can pause here and do it. Excuse me. See, now you know I'm not just putting on a show with you for you when I'm in class. I cough all the time. Okay, again. Okay, so pause it here. See if you can do this one. See if you can figure it out. We'll come back and do this in a minute. I want to make sure that we introduce our concepts. Here's another one. Number 5. Okay, number 6. Again, you can pause here and move along. Okay, number 7. See, plenty of practice for you. And you don't necessarily have to take the time to do each one of those today. We'll go over these again next week. Hopefully we'll be back together in person, right? So here we go. All right, truth tables for determining validity. Here's another one of these definitions that you need to know. Definition, validity. When an argument is valid, the conclusion follows necessarily from the premises. This is just like in introductory logic. When the premises are true, the conclusion must follow, is implied by those, and must be true. Okay? When it is valid. That's the definition, okay? So valid. If the premises are assumed to be true, then in a valid argument, the conclusion must also be true. Invalid. If an argument has true premises with a false conclusion, it is invalid, okay? So if you have true premises with a false conclusion, it's invalid. Now, these definitions become very important because you need to remember under what circumstances we're looking at these things, at this with a truth table, okay? For a valid argument, the premises must be all true and the conclusion then should follow. So that leads us to certain results. Same thing with invalid, when the premises are true. So we're gonna make a full truth table, but we're going to have to look at only the rows where the premises are true. Let me show this to you. So if a truth table shows at least, again, and notice that at least one row in which the premises of the argument are true, but the conclusion is false, then the argument is invalid. So if anywhere in the table, as you make your truth table, if you have at least one row where both of the premises or all of the premises are true and the conclusion is false, it's invalid, okay? Even if you have 8 rows where you have true premises and a true conclusion, and you have one row where the premises are true and the conclusion is false, then it's invalid. So this is why we have to do complete truth tables for these and for us to understand this, okay? Otherwise, if you don't have a row where the premises are true and the conclusion is false, otherwise it is valid, okay? Here we go. Additional, uses a truth table to determine the validity of the following brief but unusual arguments. Okay, so we have P and Q, right? Okay, now we're going to do a truth table for this, right? So for P, it's P and Q, so I have 2 variables, right? And so now I need how many rows, right? Okay, 2 times 2. So it's 2 times 2 for rows. So I'm going to go true, true, false, false, right? And for Q, and again, I'm going to do this. From here on out, I'll do this more compact form, and that I will do under Q. So now for Q, if I'm doing a truth table, think about it. Okay, so if you're doing P, Q over here, you're doing your truth table over here. True, true, false, false. True, false, true, false, right? Okay, so now all I'm doing is putting that under Q. So true, false, true, false. Now what do I do in this row? In this row, essentially going to do the same thing, and that is that because I'm simply repeating Q, I do this. I just replicate it. True, false, true, false. Okay. Now, when I work this out for my operator, right? When I work this out here, again, I'm gonna change my color. There we go. I'm gonna change my color. Let's go blue. Okay. Now I only have P on the left side, right? I only have P here, so I don't need to have anything else here. But now I need to do this operator here, right? So how does conditional work? Only when I'm assuming the antecedent is true. So only when okay. Hold up my handy dandy chart here. Let's get it nice and close, right? Because I forgot I have my camera reversed. So it's going to make it a little tougher. You'll have to look at your chart, but remember that our rule of thumb is that only one line in conditional. And since I've done it over here on the right with conditional, right? With a conditional P, if P, then Q, it's true, and only this one, because P is true and Q is false, is this false, right? All the other lines are true for conditional. So when I come back to under the conditional here, it's true, 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 right? Now, here's the challenge with this. And this is what you have to remember. And that is, remember what it means for an argument to be valid. For an argument to be valid, when the premises are true. So I'm only looking at lines where the premises are true. Those first two lines. I'm not looking at these because these are false. I don't care at all about these lines because the premises are false. When the premises are true, then I'm looking over here and I need to make sure I look at the blue, right? True, true. This argument is valid. Why? Because on all the lines where the premises is true, the conclusion is true, okay? The other way to think of it is because none of the lines where the proposition is true is the conclusion false, okay? So, I mean, either way, I mean, you can either think of it as all true premises lead to a true conclusion, or none of the true premises result in a false conclusion, right? Again, you can, with practice, this will make more sense. All right, let's move along. Here's another one, same thing. P, so the proposition, the line, the slash mark there is there to is there simply to show that it's the end of the premises. The three dots, again, just like in introductory logic, represent therefore. If Q, then P, right? You can pause it here and work this out. We're not going to work this out at the moment. We'll come back to this later because, again, we're just introducing the ideas, okay? Same thing. Now, here's two propositions, P, Q, therefore, P if and only if Q, okay? It's biconditional there. So you're going to do P, Q. Again, how many rows you're going to need? There's only two variables. 2 times 2 is 4. So you're going to need 4 rows. Again, you can pause here and work it out if you want. You can wait till next week and we'll work this out together, okay? All right, here we go. Translate the following arguments in symbolic form. Okay, some practice. This is some practice. And I'll give you a chance here. Again, you can pause. You can take the time and try to translate this into an argument. Okay, and we're still testing for validity. What you should end up with is something that looks like this, depending on the constants you use, not C and E, therefore not C. Again, we'll wait to work this out later, but you can pause here and work it out. All right, let's do another one. I can tell the future, thus it will either snow tomorrow or it will not snow tomorrow. You can tell for reading that what it is, but work it out. Do a truth table for this, okay? It should end up something like this. F, therefore, S, or not S. Okay? You see the tautology in there? It has to be it has to be true because it's using disjunction, right? All right, let's move along. We'll do you can actually do the truth table. We'll do this. This is where we'll save the fun for in person next week. Okay. But if there be no resurrection of the dead, then is Christ not risen? But now Christ is risen from the dead. So in Christ shall all be made alive. 1 Corinthians 15. Okay? Translate that. I think this is the biggest thing to practice at this point is practice your translation skills. I'm hoping that the truth table part, that while it's a little tedious and takes time, that is not so difficult. It's then learning what are we looking for with the truth table. So, again, just translate that. You can pause, and then you should end up with something that looks like that. Not R. If not R, then not C. C, therefore R. Okay? You're taking each of those propositions, putting it in a symbolic form, and then working it out. Okay? Here we go. We'll move along. You can do that. Right. Either your sister is telling lies or she is mad, or she is telling the truth. You know she doesn't tell lies, and it's obvious that she's not mad. We must assume that she is telling the truth. This is from The Lion, the Witch, and the Wardrobe. Valid or invalid. Okay? Translate it. Pause. Translate it. Here's what you should... And we're getting longer, right? We're taking more complex arguments. L or M or T. Remember your parentheses. You need to have parentheses. When you have more than two operators going on, or more than one operator going on. Okay? And then you have the next separate proposition, not L and not M, therefore T. Again, you do your truth table. Okay, they're getting longer, aren't they? Because the arguments are going. How many constants do you have? You have L, M, T. So how many rows you're going to need? 2 times 2 times 2. Now we're up, right? We're up to 8 rows, right? You can pause and do your thing. Okay, here we go. If the Son is not the same substance with the Father, then he is a substance that was made. And if that substance was made, then all things were not made through him. But on the contrary, all things were made through him. Consequently, therefore, right? He is of the one and the same substance with the Father. That's St. Augustine on the Trinity. So, pause, translate. Remember that you pick the constants. As long as your constants are consistent with what I put up with the screen, you're doing okay. That's the key here, is that be consistent in what you're doing. You don't have to have exactly the same constants, but you should end up with something that looks like this. Not F. If not F, then M. If M, then not A. A, therefore F. Okay? Then you do your truth table. Tell me whether it's valid or not. Work it out. You can pause here, and then we'll move. We're going to move on, though. Okay, that's it for this week. Where are we at here? Let's go back. Let's do one of. I'll quickly scroll through all this. And we did one of the additional exercises for equivalence and tautology. Whoops. Yeah. I'm doing this on my iPad, so let me find the right. Okay, let's go. We did. So we're doing validity. Let's do one of the translated ones. Okay? Let's do this. Here we go. Translate the following. You cannot have your cake and eat it too. Therefore, you cannot have your cake. Let's do this. Okay? Again, so in the there's the long format, which would be, I'll do that out here to the right. Okay? And that is, I forgot what color we're doing. So I have C. Okay? I have E. Right? I have not C. And then I have to do C and E, and then I have to do not C and E, right? See how this this can get really long if you're going to do a full table. In fact, I even ran out of. I have not C here, right? And you do your line. Let me use the more compact method. This one requires a little more attention to detail, and it's a little more challenging if you're not paying attention to details. But I think for most of you, you can handle this, right? So now, I have C and E. How many rows am I going to need? I'm going to need 4, right? Because I have 2 constants, and so 2 times 2 is 4. So I need 4 rows. So now under C. What I'm going to do is do under C, under E, and I'm going to do under not, and actually, let me get my eraser out here. And I'm going to do not C. That's where, if you're going to do this compact method, make sure you write your excuse me. Make sure you write your notation directly under the constant or the operator. And how I handle this is why I use different colors so that I can tell what row I'm doing. I'm going to try to be careful. So I need 4 rows, right? So under C, true, true, false, false. And this is where those details matter, okay? So then under E, true, false, true, false. Excuse me. Okay? Now, under not C, I'm going to take the C column and simply negate it, right? So C is true. It would be false, false, true, true, right? Okay? The reason why I did that is, I mean, if you really want to do this, is I could take under C is true, true, false, false, and then I negate it. I'm moving a little bit to the left, and then I get false, false, true, true. Okay, see that? Now let me change my color again so that you can see. Now, when I have parentheses, right, I need to move. I'm moving from inside to out, so I'm going to do, see blue under blue here, under the conjunction. Remember my rule of thumb for conjunction? They both must be true for it to be true. So I have true, false, 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 right? Now, you got to think about this, because when I do negation, let me do green for negation here. Now, when I do the tilde by the not C and E, now I need to, but be careful. You make sure you're negating the correct thing, that you are negating the conjunction. So what I have in blue, I need to now do over here under the tilde. So where it's true, it becomes false. False is now true. False is now true. False is now true, right? Because it's negated, and negation is flipping the truth value, right? So now what am I looking for? Validity. What is the definition of validity? Validity is in all the rows where the premises are true, the conclusion must be true. If the other way, and I think the easier way to think it, if I have a line where the premises are true and the conclusion is false, then this argument is invalid. So now, here again, here's the trick. Okay, you have to know what you're looking at. Okay, I am not looking at this first line because this is false, right? And so I'm not even paying attention to that line. Okay, now on the lines where, look at the second line. And again, I'm looking at the green there, right? I have a line right here that when the premise is true, not C and E is true, the conclusion is false, right? And by the definition of validity, if I have at least one line where a premise is true, the premises are true, and the conclusion is false, this is invalid. Okay? And in essence, my work is done. I found one row where the truth value is not the same. Now, notice that even if you look at row 3 here, okay, the premise is true and the conclusion is true. It doesn't matter, okay? When, again, line 4, the premise is the proposition, the premise is true, and the conclusion is true. But I found at least one line where the premise was true, conclusion was false. That makes this argument invalid. At least one line. Okay? Let's see. What else do I want to do? Let's do, for kicks and giggles, should we do one more? Okay, let's do this one about, I can tell the future, thus it will either snow tomorrow or it will not snow tomorrow. Okay? Take a second and translate that argument. And I'm going to, I'm looking at my notes just so I'm consistent on using my, let's see, this is number 5. I want to be consistent on using my, do I have it? Maybe I don't have this one in my notes. C or D, I can, here we go. Okay. You done translating? Here we go. Try this. You should end up with something that looks like this. F. So I can tell we used F for future, right? I can tell the future. Thus, or therefore, right? This is therefore, it will either snow, S, tomorrow, or, right, disjunction, or it will not snow, right? So S or not S, okay? And then so when I translate, I get F. Okay, now, how many constants do I have? I have 2 constants, F and S, right? And so how many rows do I need? I need 4 rows, right? Let me go back to red here. So under F, just like we're doing it always when we're starting left to right, true, true, false, false, right? Under S, okay? So I'm going to do under S, again, just like my second, I'm going to go true, false, true, false. Now, under negated S, I'm now going to I'm going to negate the values under S. So this is going to become false, true, right? Now, let me pick a different color. Let's go green. Now I'm going to do disjunction. What's my rule of thumb for disjunction? If either is true, then the argument is true. So now, true, true, true. Whoops, true. All of them are true, right? Since it's simply in the negated version of this, all the lines are true. Now, when I'm determining validity, remember, what am I looking for? Are there any lines where the premise is true? Okay? So on this line, the premise is true. This line, the premise is true. The premise is false here, so I don't care at all about these lines. I'm only looking at those first 2 lines, right? So when F is true in this argument, here we go, true. When F is true again on the second line, true, okay? And as we learned, right, this is valid. Why is it valid, though? It is valid because there are no lines where the premises are true and the conclusion is false. Okay? All the lines. Okay? this one also happens to be the argument. You'll recognize that S or not S is a tautology. Okay, right? Because all the truth values for those that S or not S is true. But this argument is valid because on none of the lines is the premise true and the conclusion false. All right? That's probably enough fun for one day for logic. We'll save something for next week. Hopefully we'll do this in person. As always, contact me if you have any questions. I'll give you my email. I'll write my Mitch at mitchss.com, right? Or you can text me. Well, you know what? I'm not going to put my cell phone number on here. Because I'm going to post this up on YouTube for you all, and I don't really want the whole world to have access to my. But I always put up my email address. So Mitch at mitchss.com if you have questions. If you're one of my students in Logic, you have my cell phone number. You can text me. If you need to, you can call if you have a question, usually texting. And this is where if you have a specific problem, question, you have a problem, just like we did in introductory, the way I've found that works best is if you have the capability to do it, is take a picture with your camera, phone, your parents' phone, your phone, whatever. Take a picture of the problem and then give me what your question is and what you're trying to figure out. That will make it easier for me to answer your question. I mean, otherwise, you can send me and you can just tell me the problem. And I'll have to look it up. But I want to make it as easy for you, and I would hope you make it as easy as possible for me. But hopefully this just quick explanation. That, guys, just plug through your text. As always, do a little bit each day and keep plugging away. Please, please, please don't try to do it all in one day. Otherwise, it doesn't sink in. You need the repetition. You need to be working on your exercises. As far as the test that you were supposed to turn in today, you can turn that in next week. I will hand out the next test next time, since it'll be our second meeting for this. But again, if you have questions, please let me know. All right. Have a great day.